ladies and gentlemen. I'm Ali, team leader of Team 5, and the purpose of this video is to show you our security guard robot that we have designed for our senior project.
I'm team member of the security robot, and I'm going to explain how it works. Basically, what it does is that it checks for intruders via motion and sound. The idea is that if it detects somebody moving or a loud sound, is going to an alarm is going to go off for 5 seconds, and then the robot is going to move and avoid obstacles. Now Chris is going to be explaining exactly how that works.
This is our project up close and personal. I'm going to explain to you exactly what's going on the project. We have several sensors. We have 2 passive infrared sensors. Those are the ones that are detecting if there's any intruders in the area. They're detecting if they're moving, if there's a change in infrared signature in the room. We also have a microphone that is picking up any sounds in the area, and that's being fed through our logic circuit over here, and that signal is going to be passed through to the microcontroller to signal if we've had somebody intruding or some sound going off in the area. The alarm, which is down here, I don't know if you can see it too well, but the alarm is that big speaker there, and it'll be pretty loud. We have some LEDs here that are for our reference. We have a power LED, we have a sensing LED. It tells us, this yellow one will tell us when the sensing circuit is ready and is being used. We have a sensing circuit power up LED where the sensors are being saturated. It'll tell us, as long as it's on, it's telling us being saturated, and once they are ready to be used, it'll turn off and it'll turn on again if they get tripped. We have the H bridges for our motors that are down here, and they are pretty much supplying the current to our motors, and they're being controlled by the microcontroller. To sum it up, that's pretty much the specifics of our project and how it runs.
Well, our project is provided with a sonar sensor that is used to detect objects, obstacles, so that while in motion it can stop and read how far it is from an object or an obstacle, so that it can decide whether it's going to continue driving or it's going to turn to avoid the obstacle. And this option has provided our project with a great vision, because now it can avoid collisions and it doesn't crash to anything, which is one of the main objectives that we wanted our project to do. So we're going to show you how our robot works, and for this test we're just going to leave it freelance everywhere here. We're assuming it's running in a small business or a small apartment or a small house, and it's going to patrol its way around, avoiding objects, looking for intruders. But in this case, none of us going to make any sound or a movement, so that none of the alarms or the sensor shouldn't detect anything, and the alarm shouldn't go off at any cost. And then we will make a sudden movement so that you can see how our sensor detects motion. And in the third case, we're going to make a loud noise so that you can see how our sensors detect noise as well. So there we go. Well, first, before I turn it on, when I turn it on, the robot's going to wait for a second to be ready and prepare, and then it's going to send a signal through the sonar to check for obstacles before it starts moving. And then it's going to move, and then it's going to stop. When it stops and make sure that it's completely stopped, it will activate the sensors to receive input from them. But it will wait for about 10 seconds for them to stabilize, and then it will start reading the sensors. And when it starts reading the sensors, you will see this yellow LED over here lights up. And when it lights up, it means that the sensors are reading, and they are like detecting if there is a motion or there is any suspicious sound. And at that time, if something is detected, the alarm will go off. If not, the LED will turn off, means that there is nothing was detected, and the motion will carry on. And this will go forever. So here we go, plugging in the battery to run the robot. and I'm gonna step up off the way as soon as I power it on. We're testing for the robot if it avoids obstacles. Here we have a couch in front of it, and don't mind the alarm because I'm speaking and one of us is moving, so it detects. But we will see. As you can see, it turned because it detected the couch in front of it, and so to avoid collisions it measured through the sonar over here, and it turned to the right to avoid it. So now there is nothing, it's clear over here, so it will go forward in the next round, and it does that so on and on and on and on, avoiding obstacles if they are with the range of less than half a meter, and avoid them. It only turns if the obstacle is within the range of half a meter, but otherwise it will go forward. But let's say the obstacle is within range of less than 30 meters, 30 centimeters, it will go back for a while and then it will turn, indicating that it was too close and it doesn't want to crash. So that's what it does. So assuming we're here and it's too close to the couch, so it will avoid it by going back and then turning to the right. So it has a better way of movement. It will detect again if it's too close. It will go for if it's too close, it will turn again. If not, it will go forward for a little bit and then it will turn. As it does that in each iteration.